Okay, so binomial probabilities. Binomial is speaking about probabilities that can be broken up into two categories. What you want, what you don't want. Success, failure. They handle situations where you have a fixed number of trials and a particular number of successes. Each probability has to be independent, and the probability has to be the same for the whole situation. So here's our first example. And by doing this example, we'll kind of figure out the pattern of how to work with these problems. So what is the probability that you get 4 one time when you roll a die 4 times? So the first question you have to ask yourself is, what's a success? In this case, a success would be rolling a 4. And what's the probability of that? Well, 4 is one side of 6 sides on a die, so the probability of a 4 would be 1/6. The other group then would be not a 4. And the probability of not rolling a 4 would be 5/6. So these are the two groups that makes this binomial. We know we're going to do this problem 4 times, and we're looking for one time to be a 4. So what could happen? Well, maybe we get the 4 first, and then we get 3 that are not 4s. So we would have 1/6, 5/6, 5/6, 5/6, and if we're doing things in a row, we would multiply all of these together, and so we'd have 125 over 6 to the 4th, or 6 times 6 times 6 times 6 times 6, which is 1,296. But that's not the entire probability, because no one said that the 4 had to be the first roll. The 4 could have been the second roll, or the 4 could have been the third roll, or the 4 could have been the fourth roll. There are 4 places where that 4, that success, could have happened, and each one of these probability situations would have had a probability of 125 over 1,296. So we have to do the probability one time, and then think about how many different places could the 4 have happened, and put those together to make the total probability. So we would say there's 4 times 125 over 1,296 for a total probability of 500 over 1,296. Remember, you can simplify your fractions. So that would be 125 over 324 for a simplified answer. Okay, so next question. What if we flip a coin 50 times? What is the probability you get 28 heads? Now clearly you don't want to do this problem by making 50 slots and filling in the probabilities. So let's make the groups. We have the probability of success, which in this problem, since they're asking us about heads, would be heads. And the probability of getting heads when you flip a coin is 1 out of 2. And the other group this time would be tails, which is also a probability of 1 out of 2. and we're flipping the coin 50 times, so the number of trials is 50. So last time we had a series of 1/6 and 5/6. This time we have a 1/2 for heads and a 1/2 for tails. How many heads will we need in this probability? Well, since it says we're looking for 28 heads, then we would need a 28 on the heads. And if we're working with 50 trials, we would need 50 minus 28, which is 22 for the number of tails. So that would cover all of our 50 slots, our 50 probabilities, but it wouldn't fix the order question. How can we figure out how many different places there are to place those 28 heads out of the 50 slots? Well, we want to know basically how many groups of 28 can I make. So we're going to go back to permutations and combinations and do a combination. I have 50 coin flips. How many groups of 28 could possibly have heads? And this will be our 3-part math problem. We'll multiply by 50C28, and then the probability, 1/2 to the 28th times 1/2 to the 22nd. This can be done all in the calculator, as long as you remember to put a multiplication symbol between the combination and the first probability. And if you're using fractions, make sure the fractions are in parentheses, same as when you write it. Okay, just typing this in here. So the answer, the probability is 0.0788, which is about 7.88%. Okay, a third example. Suppose 65% of boys said they had played a certain video game. Find the probability that in a class with 14 boys, exactly 8 have played the game. So here the probability is given to us as a percent. So what we want in the probability question is people who've played the game. So played the game. And what we don't want is people who've not played. So there's our two groups. Probability is 65%. So percent, remember, means out of 100. So it's either 65 out of 100 or the decimal version, 0.65. For 65%, we want to take 100% minus 65, leaves us 35. So 35 out of 100 have not played the game, which is 0.35 if you wish to have the decimal. And the class had 14 boys, so the number of trials is 14. So now we need our 3-part question. We have our two groups probability, played and not played. We're looking for 8 people having played the game, so we want to put a probability or an exponent of 8 on the probability for playing the game. And then 14 minus 8 is 6, so we want to put a 6 on the amount of people who have not played the game. And then to figure out how many groups there are, we need a combination at the front. 14 boys. How many groups of 8 can you make? And let's see what the answer is. Okay, and that is 0.17 0.076 if I round to 3 decimal places. Okay, one final example. Suppose 5% of cars did not stop at a certain stop sign. If you watch the next 45 cars at the stop sign, find the probability that exactly 6 of them will not stop. So we're asking about will not stop. So that's what we want. So not probability of not stopping is 5%, so 5 out of 100, or 0.05. The probability of stopping is 95 out of 100, or 0.95. And the number of trials, it says we're going to watch the next 45 cars, so 45. So there's our two groups. 0.05 for not stopping, and 0.95 for stopping. And again, we're watching the next 45 cars. Find the probability that 6 of them will not stop. So we'll put a 6 on the 0.05. And 45 minus 6 is 39. So 39 do stop, sorry. It's always a little more stressful when what you are counting is actually the not. It's a little more confusing. You have to be careful. And we need our combinations at the front. If we have 45 cars, how many groups of 6 would be the ones to not stop? And that would be 0.0172.